Hey, hi all. So once again, welcome to Mathematics Mania YouTube channel. So in our previous video, we saw proving the Leibniz theorem, and here we will see solving few of the problems using Leibniz theorem and its application. And before I start, I would like to remind you that if you are liking our videos, please do subscribe to our channel and support. Yeah, so we'll start with the first question. That is, if y raised to 1 by m plus y raised to minus 1 by m is equal to x, then using Leibniz theorem prove that x square minus 1 into yn plus 2 plus 2n plus 1 into x of yn plus 1 plus n square minus m square into yn equal to 0, where yn plus 2 is nothing but n plus 2th derivative of y, and yn plus 1 is nothing but n plus 1th derivative of y, and yn is the nth derivative of y. So the question itself, when we see, we will be able to get, when I say yn plus 2th derivative, so first I should have second order derivative, then only I will be able to apply the nth derivative to it. So n plus 1, so if I am applying nth derivative to first order derivative, I will get yn plus 1, and if I am applying nth order derivative for y, I will be getting yn. Yeah, so in order to prove that, let's start with whatever is given. So whatever is given is, this is y raised to 1 by m plus y raised to minus 1 by m is given as 2x. So what I will do, y raised to 1 by m plus y raised to minus 1 by m can be written as 1 divided by y raised to 1 by m will be equal to 2x. Cross multiply it here, so this will become y raised to 1 by m the whole square plus 1 will be equal to, divided by y raised to 1 by m will be equal to 2x, which means so this y raised to 1 by m, I'm moving to that side. So what happens, y raised to 1 by m the whole square, so this term I am taking this side, so this will become minus 2x raised to, this I have multiplied that way, that side, so minus 1 by m plus 1 will be equal to 0. Now this is of some of the quadratic equation, right? See, y raised to 1 by m the whole square minus 2 into x into y raised to 1 by m plus 1 equal to 0. So we know that ax square plus bx plus c, the quadratic equation, we can solve it using a formula, that is x is equal to minus b plus or minus root of b squared minus 4ac divided by 2a. So we will apply the same thing here, but for the sake of simplification, y raised to 1 by m is little difficult to write. So what I will do, put y raised to 1 by m equal to k, so that it will be simple for me to write. So what happens, so k square minus 2kx plus 1 equal to 0. I just replaced y raised to 1 by m by k, so that it will be easy for me to calculate. So now I will apply the formula. So what happens, the value of k will be equal to minus b, that is minus 2kx is there, so that will become 2x plus or minus root of b square, 2x square will become 4x square minus 4ac, 4 into a, the coefficient of k is 1, so 1 plus c, that is also 1, so that will be equal to 1, divided by 2 into a, that is 2, so that will be equal to, so see here, 4x square minus 4 is there, so I will take this 4 common outside, and when I take it outside the root, so that will become 2, the square root of 4 is 2, so that will be 2 into x plus or minus root of x square minus 1 divided by 2. So 2 here also 2 is there, right? So 2 I can cancel it, so which implies k will be equal to x plus or minus root of x square minus 1. That's it, right? So see here, y raised to 1 by m is equal to k. So what happens, therefore y raised to 1 by m will be equal to x plus or minus root of x square minus 1. So now I have got y raised to 1 by m is equal to some expression. So again see here, so 1 by m I will not be, it will be difficult for me to differentiate if I have this 1 by m in y. So what I will do, I am going to take the power of m on both the sides. So take m to m on the power on both the sides, on the power both sides. So what happens, y raised to 1 by m raised to m will be equal to x plus or minus root of x square minus 1 raised to m. So what happens here, m will get cancelled, So y will be equal to x plus or minus root of x square minus 1 raised to m. Call it as equation number 1. So now we have got the value, the expression for y. Now we can start differentiating. Differentiating equation number 1 with respect to x. What happens when I differentiate this with respect to x? Y1 will be equal to, see it here, x plus root of x square minus 1 raised to m. So this is of an exponential form, x raised to m, x raised to n. So that will become nx raised to n minus 1. So that will become m into x plus root of x square minus 1 raised to, this will become m minus 1. X raised to n, the derivative is nx raised to n minus 1 into, apply the chain rule, the derivative of x plus or minus root of x square minus 1 we have to take. So what happens? So we have to take the derivative of this term also. It will be derivative of x is 1 plus or minus this root of x square minus 1 derivative also we have to take. The derivative of root x is 1 over 2 root x. So that will become 1 divided by 2 root x square minus 1. Also we have to take the derivative of this x square also, applying the chain rule. So this will become 2x, right? So that will be equal to m into x plus or minus root of x square minus 1 raised to m minus 1, right, into see 2 root x, this 2 and this 2 can be cancelled. So this x square minus 1 cross multiply it here. So this will become x square minus 1. So that will be root of x square minus 1 plus or minus x divided by root of x square minus 1. So observe here, root of x square minus 1 plus or minus x raised to 1, and this is x plus or minus root of x square minus 1. This term is same, right? X plus or minus root of x square minus 1 raised to m minus 1, and this is root of x square minus 1 plus or minus x. So since these two terms are same, a raised to m minus 1 into a raised to m. So m minus 1 plus 1 will become a raised to m. So that will be equal to m into x plus or minus root of x square minus 1. So m minus 1 plus 1 will become m. So that will be equal to divided by x square minus 1, which implies, see here what happens. See here, from 1 what is the value of y? X plus or minus root of x square minus 1 raised to m can be written as y itself. So what happens? y1 will be equal to m into this complete term can be written as my, right? See here, y is equal to x plus or minus root of x square minus 1 raised to m. So this will become y is equal to my divided by root of x square minus 1. So that will be equal to root of x square minus 1 into y1 will be equal to my. Yeah, so now we will square on both the sides. That is root of x square minus 1 into y1 the whole square equal to my the whole square. When I do the whole square here, this will become x square minus 1 into y1 square will be equal to m square y square, right? y1 square is nothing but dy by dx of whole square, that is the first derivative square, right? So again now we have to apply the, again we will differentiate with respect to x again. Differentiating with respect to x again, what happens? Now we have to apply the product rule here. So let's apply first function into, that is x square minus 1 into derivative of y1 square. Derivative of x square is 2x, so derivative of y1 square will become 2y1, and we have to differentiate with respect to with respect to x again, that is dy by dx. So that will be y2, right? y1 square, so y1 square will become 2y1, and the derivative of y1 is y2, right? Plus here the derivative of x square minus 1 is 2x into y1 square will be equal to, m square is constant, the derivative of y square is 2y, and we have to take y1 here, that is differentiate y with respect to x again, that will become y1, right? So this is the one. So if we observe this term, we have y1 square, y1 in all the terms. So I will take the y1 and cancel out. So what happens? X square minus 1 into y2. So I have 2 here. I have 2 here, so I can see in every term 2 is common. 2 is there, so I will cancel this 2 because it is there everywhere. And y1 also I can cancel like this. Okay, so now what happens? X square minus 1 into y1, x square minus 1 into y1, y2, sorry, this I have cancelled, y2 plus x y1 will be equal to m square y. Okay, so let me rewrite it. X square minus 1 into y2 plus x y1 minus, let me take to this side, so this will become minus m square y will be equal to 0. Now we have got the expression in terms of y2, y1 and y. Now applying the Leibniz rule. Okay, applying Leibniz rule, what happens? Leibniz rule, we have to take the nth derivative of the first term, and y2 will keep as it is, and the first function will keep on decreasing its derivative, and the second function will keep on taking the 1th derivative higher. Okay, so what happens? We have to apply the Leibniz rule for each term in this equation. So we have 3 terms here, so for all the 3 terms we have to apply the Leibniz rule. So what happens here? So I will take this y2, y1 and y as the first function, and this x square minus 1 x, and this m square, this one will be the second function. So what happens? See, nc0, the rule applies like this, right? nc0, take the nth derivative of y2. So nth derivative of y2 will be yn+2, and keep the first function as it is, that is x square minus 1, right, plus nc1. So take the n-1th derivative of y2, so that will become yn+1 into the derivative of x square minus 1. X square minus 1 derivative is 2x plus nc2. This will become yn+2, so now it will become yn. So yn into the derivative of 2x will be 2. So see here, so if I am going to take the next derivative of v, so the second function has already become 2, so I can stop taking the derivative here, because the next term when I take, the derivative of 2 will become 0. So everything else from this term will be 0. So I can stop taking the derivative. So this will be the derivative, the complete nth derivative for the first term, right? So now I will take the same thing for the second term, so that is x y1. So now what happens? Into nc0, x I am keeping as it is, and this will become nth derivative of y1 is yn+1, right? yn+1 plus nc1, the derivative of x is 1, right? The derivative of x is 1, and this yn+1 we will reduce by 1, so that will be yn into the derivative of x is 1. So here also we can stop taking derivative, because once we get the constant term, so there is no need of to take the next derivative, because the derivative of a constant will become 0. So plus m square y, m square is constant already, so nth derivative of y is yn. So this is minus, sorry, I have to take minus, m square yn will be equal to 0, right? So we have already applied the Leibniz rule now. So now let's keep simplifying it here. So this will be equal to nc0 is nothing but 1, so this will become x square minus 1 into yn+2 plus nc1 into yn+1 is n itself, so n into 2x, that will become 2nx into y of n+1 plus nc2 is n into n-1 factorial into n-2 factorial divided by n-2 factorial, that is ncr is n factorial divided by r factorial into n-r factorial. So this will become n into n-1 divided by 2, right, into this is yn. So here also 2 will be there, and this 2 and this 2 will get cancelled. So this is n into n-1, so this will, because 2 was there here, 2 I have moved this side, so 2 will get cancelled into yn plus nc0 is nothing but 1 itself, so that will become x into yn+1 plus nc1 is n, so that will become n yn minus m square yn I am writing as it is, this will be equal to 0. So this will be x square minus 1 into yn+2, right, plus 2nx into yn plus 1. N into n minus 1 will become n square minus n into yn plus x into yn plus 1 plus nyn minus m square yn will be equal to 0. Now observe here 2nx yn plus 1 and here xyn plus 1 is there. Xyn plus 1, xyn plus 1. So I can take this xyn plus 1 common outside, and from this yn term n square yn minus nyn, and this is plus nyn. So 1 minus nyn and 1 plus nyn will get cancelled. So x square minus 1 into yn plus 2, right? And this will be 2nx yn plus 1 and here xyn plus 1. So xyn plus 1 is common. So this will become 2n plus 1 into x yn plus 1, right? So here n square minus n square minus n, and this is plus n minus m square, right, into yn. See, in yn term 1 minus nyn is there, 1 plus nyn is there, minus m square yn will be equal to 0. This plus n and minus n will get cancelled, which implies x square minus 1 into yn plus 2 plus 2n plus 1 into x into yn plus 1 plus n square minus m square yn will be equal to 0, which was supposed to be proved. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.